So today we're going to talk about 2.2. We are going to be graphing polynomial functions. So yesterday we talked about a more specific type of polynomial, which was our quadratic function. So we know that quadratic functions were x squared graphs or parabolas. They have parabola shapes, that U shape. Today we're going to talk about the more broad polynomial function. So poly means many. So we're going to be graphing something with many terms or many degrees. There's two things that we have to keep in mind when we are graphing our polynomial function. The first is that it has to be continuous. So looking at the two graphs on the bottom, the one on the left is continuous. I could draw it with a pencil without picking my pencil up the whole way. The one on the right is not continuous because we have this gap here. So this one is not continuous, so it is not a polynomial function. The second thing is that our graph has to be smooth. So smooth meaning that it has rounded turns. So this is an example of a smooth graph. The one on the next page is an example of not a smooth graph. So this one has a sharp turn here. So it is not a polynomial function because it is not smooth. So two things we have to keep in mind when we're drawing our polynomial functions is one, that it has to be smooth, and two, that it has to be continuous. So smooth and continuous. Now we're going to go into how to draw our polynomial functions. There's a couple patterns that we're going to talk about that we're not going to draw our graph exactly. It's going to be just like a sketch of our graph, but there's a few things that we need to draw in order to sketch the graph, or we need to know. So when n is even, meaning that our degree of the highest term is even, our graph is going to be similar to an x squared graph. So we know that an x squared graph looks like a parabola. It could either be a parabola that opens up or a parabola that opens down. Bless you. If we have anything with an even degree, like x to the 4th power, x to the 6th power, x to the 8th power, it's going to be similar to a parabola shape. It'll do a little bit more in the middle, like it's not just going to be U-shaped, but the end behaviors of our graph are going to be the same as the parabola. So when we have an even degree, just like a parabola, the end behavior of our graph is going to go in the same direction. So if we have a leading coefficient that's positive, just like a parabola, our end behavior is going to go up and up. If our leading coefficient is negative, our end behavior is going to go down and down, just like our parabola that goes upside down. The arrows at the end are going to go in the same direction when we have an even exponent. Bless you. Now when we have an odd exponent, so this would be like x to the 3rd power, x to the 5th power, x to the 7th power. Any odd exponent, our graph is going to be similar to an x cubed graph. So when we have an odd degree, the end behavior is going to go in opposite directions. Bless you. So when it's positive, the left arrow is going to go down and the right arrow is going to go up. Think about if this was like a line, our overall slope of the line would start by going down and end by going up. It's increasing. Our overall slope would be increasing when the left arrow goes down and the right arrow goes up. If it was a negative coefficient, it would flip, so the left arrow would go up and the right arrow would go down. So the end behavior is going to go in opposite directions. Let's look at example 1. So example 1, we are going to sketch the graphs for A, B, and C. It's just going to be a sketch, so just a rough estimate of what our graph looks like. But we're going to start with our parent function for x to the third power. Our x to the third power graph looks like this. This is our parent function. So it has an odd exponent, so the end behavior is going to go in opposite directions, and it's positive, so the overall slope is going to be increasing. Now with A, B, and C, we have some transformations happening to it. With A, when we multiply by a negative out front, what does that do to our graph? It reflects it. It's a reflection, or it flips it. So now that we are decreasing, we're going to flip our graph, so our overall slope is going to be decreasing like this. The end behavior still goes in opposite directions, but since our leading coefficient's negative, it's going to start by going up and end by going down. Overall slope's negative. For B, when we add 1 to the outside, what does that do to our graph? It goes up 1. Awesome. Up 1. So we're going to keep the same shape of our parent graph because this one's positive, so it's going to be increasing, but we're just going to shift it up 1. So our graph is going to look like that. All right, and lastly, let's do C. When we subtract 1 on the inside, what does that do to our graph? It moves it to the right 1. Awesome. So we keep the same shape of our graph. We're just going to shift it to the right 1. So it'll look like this. Next page just talks about the end behavior. So we can determine our end behavior using the leading coefficient test, which I kind of mentioned a lot the last couple slides. But when n is odd, so when our degree is odd, if our leading coefficient is positive, then the end behavior of our graph is going to start by going down and end by going up. We said when it's odd, it goes in opposite directions. Now to put this into words, we would say that it falls left and rises right. I think it's helpful, draw the arrows first so you can kind of see what's your overall slope of your graph. Is it increasing? Is it decreasing? You can tell if it's positive or if it's negative, and then put the words to it. So once you draw the arrows, then put the words that go with it. Now, when our leading coefficient is negative, it's going to be the opposite. So we still have arrows that go in opposite directions, but our overall slope is going to be negative. So our graph is going to start by going up and end by going down. So here it would rise right. And, oh, just kidding, that's left. Rises left and falls right. Next, when n is even, so when our degree is even, our end behavior is going to go in the same direction. So when our leading coefficient is positive, both the arrows are going to go up, similar to an x squared graph. So we would say rises left and rises right. When our leading coefficient is negative, they're both going to go down, similar to a negative x squared graph. So it would fall left and fall right. So looking at example 2. We want to use the leading coefficient test to describe the right and left-hand behavior of the graph. So here we're looking at our highest degree term. We have negative x to the third power. So is our exponent even or odd? It's odd. So are they going to go in the same direction or opposite directions? Opposite directions. Now is our leading coefficient positive or negative? Negative. So how's our graph going to start? What's the left arrow going to do? The left arrow goes up, the right arrow goes down. Our overall slope would be decreasing. So we would say rises left and falls right. All right, let's look at 1. Which term are we looking at? The first term here, negative 3x to the 12th power. That's our highest degree term. Is our exponent even or odd? It's even. So do we go in the same direction or opposite directions? Same direction. Are they both going to go up or both go down? Both go down. Our leading coefficient is negative, so they're both going to go down. So we could say falls left and right. Let's look at number 2. Which term are we looking at here? The first one is our highest degree term. Is our exponent even or odd? Odd, so they go in the same direction or opposite? Opposite directions, and if it's a negative leading coefficient, what does that tell us? What's the left arrow going to do? The left arrow goes which way? Up. The left arrow goes up, and the right arrow goes down. So we would say rises left and falls right. So our overall slope would be decreasing. So this is a negative coefficient. Let's look at number 3. Which term are we looking at here? Five x to the 7th power. Be careful here. It's not the first one. It's the one with the highest degree. So our highest degree term is 5x to the 7th power. So is our exponent even or odd? Odd. So do they go in the same direction or opposite directions? Opposite. And if our leading coefficient is positive here, what's the left arrow going to do? Left arrow goes down, right arrow goes in the opposite direction, so it'll go up. So we would say falls left, rises right. All right, next, to help us with graphing, we need to find the zeros of our function. So the zeros is the same thing as the solutions, which is the same as the x-intercepts. So we find the zeros, which gives us the x-intercepts of our graph. And to find the zeros or to find the solutions, we factor. So all 4 of these things are essentially asking for the same thing, but just in different ways. So zeros, solution, x-intercepts all mean the same thing. We find them by factoring. So for example 4, let's find all the real zeros. So I'm going to set f of x as 0. I want to set my function equal to 0. What would we do to solve for x here? We want to factor. How would we factor? Take out an x. Always take out the GCF if you've got one. Now we're not dividing the x out. We're just putting it out front. The x is going to give us an answer, so we can't get rid of it. We got to put it out front. When we take out the x, we're left with x squared minus x minus 2. Now what are 2 factors of negative 2 that add to negative 1? Negative 2 and positive 1, perfect. So when I write this into my factors, I've got x times x minus 2 times x plus 1. To solve, we're going to set them all equal to 0. So we have x equals 0, x minus 2 equals 0, and x plus 1 equals 0. So x equals 0 is already solved for us. Got to solve the other 2, so we have x equals 2 and x equals negative 1. So one helpful hint is that whatever your highest degree is, that's going to be the number of zeros that we have. Now, sometimes they might be imaginary, so it might not be a number that touches the x-axis. Sometimes you might have multiple of the same 0, but this is going to be the total number of zeros that you'll have. So it's kind of helpful to see, okay, I have x to the third power. If you only got 2 answers, you might have missed something. So just check your work that way. One other thing that I want to mention on the homework, sometimes some things don't factor. So if it doesn't factor, what should we do? Quadratic formula, our favorite. We want to do the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac over 2a. So if something does not factor, there is a couple, 1 or 2. You might have one on the 2.1 homework that doesn't factor, or one on the 2.2. You want to use the quadratic formula if it's a quadratic function. So if you get it down to x squared and it doesn't factor, use the quadratic. So let's graph example 4. So I'm going to start by putting my zeros on my x-intercepts. My x-intercepts here, I've got a point at 0, a point at 2, and a point at -1. We also want to figure out our end behavior. So we look at our highest degree term. Is our exponent even or odd? Odd. So are they going to go in the same direction or opposite directions? Opposite directions. Our leading coefficient is positive. So what's the left arrow going to do? The left arrow goes down, the right arrow goes up. Perfect. Our overall slope would be increasing since our leading coefficient is positive. So my left arrow goes down. Out of my points on my graph, out of all of them, the one farthest to the left, I'm going to draw an arrow that goes down. And my right arrow goes up. So out of all of my points, out of the one farthest to the right, I'm going to draw an arrow that goes up. So this is the end behavior. This is what your point farthest to the left and farthest to the right is going to do. Now let's talk about multiplicity. What are we going to do at each of these points? How many x equals zeros did I have? 1. Just 1 x equals 0. So we have a multiplicity of 1 at x equals 0. Or you could say no multiplicity because we don't have multiple of them. But it helps to know we have multiplicity of 1. 1 is an even or odd number? Odd. The amount of this 0 we have is odd. So do we touch and turn or do we cross the x-axis? We're going to cross at the x-axis. How many x equals 2 do we have? 1. So we have a multiplicity of 1. Is 1, so is the amount of this answer even or odd? It's odd. The amount that we have is odd. Yes, 2 is an even number, but we only care about how many we have of them. So if we have odd multiplicity, do we touch and turn or do we go across? Cross. We're going to cross at 2. And then same thing, how many x is equal to -1s do we have? 1. So we have a multiplicity of 1. Is 1 an even or odd number? Odd. The amount that we have is odd. So do we cross or do we touch and turn? We're going to cross at -1, 2. So at all 3 of our points, we're going to cross the x-axis. So at -1, I'm going to start at the left. So I'm just connecting my dots together. I'm going to cross the x-axis. I'm going to make my way over to 0. I'm going to cross the x-axis. Then I'm going to make my way over to 2, and I'm going to cross the x-axis. So our graph will look like this. Last thing we're going to talk about today is the multiplicity. So multiplicity is if we have repeated zeros. So multiplicity is the amount of that answer that you have. So it's not saying that our answer is odd or even, it's how many of that answer we have. So if the amount of that answer is odd, so if I had, let's say, x equals 2, x equals 2, and x equals 2. Yeah, 2 is an even number, but the amount of that number that I have is odd. Then our graph is going to cross at the x-axis. So I'll draw an example of that here. So we would have a 0 at x equals 2, and our graph is going to cross the x-axis. It's going to go through that point. If our multiplicity is even, so let's say I had x equals 0 and x equals 0. I have two of them. So the amount of that answer we have is even, then our graph touches and turns at the x-axis. But it does not cross the x-axis. So it kind of bounces off the x-axis. So if I had another point at 0, depending on which direction we're coming from, but let's say we were down here, our graph would touch and turn at the x-axis. So it doesn't go through. So let's sketch the graph for number 8. First thing we want to do is find our zeros. How would I find the zeros here? Factor. How would we factor? How do we factor? Is x to the second the highest one that I could take out? X to the third power. Let's take out our greatest common factor, x to the third power. We're left with 3x minus 4. Once we factor, this is all we can factor, so we're going to set each of them equal to 0. So I have x to the third power equals 0, and 3x minus 4 equals 0. So x to the third power equals 0. This is technically 3 of my x's are going to equal 0. So we have x equals 0, x equals 0, and x equals 0. While we're here, let's talk about our multiplicity. How many x equals 0 do I have? 3. So I've got a multiplicity of 3. Is 3 even or odd? Odd. If we have odd multiplicity, do we touch and turn or do we cross? We're going to cross the x-axis. Let's solve for the other zeros. So I'm going to add 4, bless you, and then divide by 3. So we get x equals 4/3. How many x equal 4/3 do I have? 1. So I've got a multiplicity of 1. Is 1 even or odd? Odd. If we have odd multiplicity, do we touch and turn or go through? We go through. We're going to cross the x-axis. Last thing we want to do is figure out our end behavior. If you want to put these points on the graph now, you can, but let's figure out our end behavior. We're looking at our highest degree term. Is our highest degree even or odd? Even. So are they going to go in the same direction or opposite directions? Same direction. Are they both going to go up or down? They're both going to go up because our leading coefficient is positive. Now let's put all of this on our graph. So I've got a point at 0. So I'm going to start by graphing my zeros here. And then another point at 4/3. 4/3 is like 1 1/3, so it's a little bit more than 1. So I'll put a point there. So we have our 2 points. Let's do our end behavior next. We said that the left arrow is going to go up and the right arrow is going to go up. So out of my point farthest to the left, I have an arrow that goes up. out of my point farthest to the right, I have an arrow that goes up. What do I do at 0? What did we say that we're going to do? Do we cross or touch and turn? We cross. We had odd multiplicity, so we cross the x-axis there. What do we do at 4/3? Again, we're going to cross the x-axis. We cross the x-axis there. So this is what a sketch of our graph looks like. This is not exact. It does look like a parabola, but it's just an estimate. We don't have any values on our y-axis because we're not sure how low or this graph is going to go. We don't know what happens in between these 2 points without plugging in more points to find it. But this is all we're looking for. We're just looking for a sketch of your graph. I need to see you plotting the zeros. I need to see your end behavior, and I need to see, are you crossing the x-axis or are you touching and turning? All right, so the last 2 examples, we're going to do everything together. So we are going to determine the end behavior, find our zeros, the multiplicity, and then the action that it's doing at the x-axis. We're not going to worry about how many turns. We're just going to graph it. So looking at the first one on the left, let's solve it first. So we want to find the zeros. We're going to make f of x 0. And to find the zeros, we have to factor. What do we do when we have 4 terms? Group them. Group the first 2, group the second 2. What's the GCF from the first group? X squared. When we take out an x squared, what are we left with? X plus 1. What's the GCF from the second group? -4. What are we left with when we take out -4? X plus 1. Awesome. The inside parts have to be the same in order to group them. So if they're not the same, you maybe did something wrong or maybe you can't group them. So the inside parts are the same. We're going to put those together. X plus 1. The outsides are going to go together. So we have x squared minus 4. Now from here, if you set them each equal to 0, and you do the math correctly, you can find your answers, but this can be factored more. How can we factor it more? We could do that to solve, but it can be factored more. Awesome. X squared minus 4 is the difference of squares. Difference of squares. So this factors into x plus 2 times x minus 2. Awesome. So we've got x plus 1 times x plus 2 times x minus 2. Now that we've factored it all the way, we can set them equal to 0. If you set them equal to 0 in the step before, when you take the square root of both sides, make sure you put plus or minus. That's where you might go wrong here. So helps to just factor all the way. So when we set them equal to 0, we get x equals -1, x equals -2, and x equals +2. Now on WebAssign, it wants it as a comma-separated list. I think it may want it in order too. So just make sure you read the directions on how WebAssign is going to want it. You can list them all together. We could say x equals -2, -1, and 2. Either way on the test is fine. I'm going to leave them separated because that's going to help me with my multiplicity. So I've got x equals -1, x equals -2, and x equals 2. Before we get to multiplicity, though, I'm going to put these on our graph. So we're going to cross the x-axis at -1, -2, and 2. So we've got 3 points on our x-axis. Let's also find the end behavior. Which term are we looking at for the end behavior? The highest degree term. So our highest degree is x to the 3rd power. Is it even or odd? Our exponent is odd. So do they go in the same direction or opposite directions? Opposite directions. And our leading coefficient is positive. So what does that tell us the left arrow is going to do? Left arrow goes down, the right arrow goes up. So we would say that the left falls and the right rises. We can put these on our graph. Out of my point farthest to the left, I'm going to have an arrow that goes down. Out of my point farthest to the right, we have an arrow that goes up. Now let's see what we do at each point. Let's connect our dots. We're going to talk about multiplicity. How many x equal negative 1s do I have? 1. So we have a multiplicity of 1. We'll talk about whether it's even or odd in a second, but let's go to the next one. How many x equals negative 2 do I have?
1.
So we have a multiplicity of 1 here also. And how many x equal 2s do I have? 1. So we've got a multiplicity of 1. Now we have the same multiplicity for each of these. So is our multiplicity even or odd? Multiplicity is odd. Remember, we're talking about how many of each we have. Since they all have the same multiplicity, I'm just going to save a little bit of effort there. I'm just going to group them together. So our multiplicity is odd. What does that mean that they're going to do at the x-axis? Are they going to touch and turn, or are they going to cross and go through? They're going to cross. So here it asks, do they touch and turn or go through? Through is the same thing as saying cross. So they are going to cross. So now let's apply this to our graph. At each point, we're going to cross the x-axis. So I'm going to start at the left. I'm just going to go off of where my arrows are. So here I would cross the x-axis, make my way over to negative 1. I'm going to cross the x-axis, make our way over to 2, and we're going to cross the x-axis. So our graph will look like this. Now remember, this is just a sketch of our graph. If you were to put this into Desmos, it would give you something a little bit different. The heights might be different of your max and mins. Might do a little bit, something a little funky in the middle. But this is just a sketch. What we're looking for is your zeros, your x-intercepts. So same thing, zeros and x-intercepts are the same. We're looking for your end behavior and the action at the zero. So are you crossing at the zeros, or are you touching and turning? Perfect. Let's practice one more. So do GLEX. What should we do first to find the zeros? Awesome. We want to take out the GCF. So I'm going to take out a 2x. I'm going to leave that on the outside. What are we left with?
X4 minus 16.
Awesome. X to the 4th power minus 16. Can we factor this anymore? How? It's a difference of squares again. X to the 4th power is a perfect square. So this again is the difference of squares. What does it factor into? Let's do one step at a time. Let's just factor this first. What would it factor into? Awesome. X squared minus 4 and x squared plus 4. Now, can we factor this anymore? What factors more? The x squared minus 4, this one, is the difference of squares. So it factors into x plus 2 and x minus 2. Perfect. Can I factor x squared plus 4? Is that the difference of squares? What does difference mean? Subtract. Am I subtracting with x squared plus 4? No. So x squared plus 4 cannot be factored anymore. It is just x squared plus 4. It's not the difference of squares. We can't factor it anymore. So these are all of our factors. So next, let's set each one equal to 0. So we have 2x equals 0, x plus 2 equals 0, x minus 2 equals 0, and x squared plus 4 equals 0. So with the first one, 2x equals 0, when we divide both sides by 2, what does x equal? 0. What does x equal in the next one? -2. Awesome. And then x equals +2. And then with our last one, let's do a little bit of work to solve. We're going to subtract 4 on both sides. We get x squared equals -4. What would we do next? Square root both sides. Can I take the square root of a negative? No. It would give us an imaginary number. But imaginary numbers cannot be zeros. They are not x-intercepts when they're imaginary. So this does not give us an answer. So in the beginning, we knew that we were going to have 5 zeros. 2 of them just so happen to be imaginary, but the other 3 are real. So now we really only have 3 zeros. So for our zeros, I have x equals 0, x equals -2, and x equals 2. So let's put this onto our graph. So I'm going to cross the x-axis. I'm going to have a point at 0, a point at -2, and a point at 2. Any questions so far? All right, next let's do our end behavior. So we're looking at our highest degree term for the end behavior. What's our highest degree? Is it even or odd? Odd. Our 5th power is odd. So are they going to go in the same direction or opposite directions? Opposite directions. And our leading coefficient is positive. So what does that tell us? What's the left arrow going to do? Left arrow goes down, right arrow goes up. So we would say that it falls left and rises right. So let's put that onto our graph. Out of our point farthest to the left, we're going to have an arrow that goes down. Out of our point farthest to the right, we have an arrow that goes up. Now let's see what we do at each point. Let's connect our dots, but let's talk about the multiplicity. How many x equals zeros do I have? 1. So we could say a multiplicity of 1. How many x equal -2's do I have? 1. So again, we have a multiplicity of 1. And how many x equal 2's do I have? 1. So again, multiplicity of 1. So is our multiplicity even or odd? Odd. Remember, we're talking about the amount that we have of each answer. We've got 1 of each, so our multiplicity is odd. Since they all have the same multiplicity, I'm just going to group it together here. We've got odd multiplicity. When we have odd multiplicity, do we touch and turn or do we cross the x-axis? We cross the x-axis. Awesome. We're going to cross at the x-axis. So let's put that on our graph. Starting at -2, I'm going to cross the x-axis at that point. We're going to make our way over to 0. We're going to cross the x-axis. And we're going to make our way over to 2. And we're going to cross the x-axis. So this is just a rough sketch of our graph. Yeah, and if you put it into a graphing calculator, it'll give you something that looks a little bit different just because it's going to be a little bit more complex in the middle, especially with that imaginary answer that we don't do anything with. But this is what we're looking for. On the homework, it'll give you graphs for your multiple choice. Try to graph it on your own. Find the zeros, find the end behavior, and if it crosses or touches and turns at the x-axis, and then just use process of elimination from there, and you'll be able to figure out which graph you're looking at. So it'll look a little bit more complex on the web assign, but it'll have these important things. It'll have the zeros, it'll have the same end behavior, and it'll cross at the points that it's going to cross at. All right, I think I mentioned it in this class yesterday, but I can't remember. What happens if something does not factor? Awesome. If it does not factor, if it is an x squared, so if it is a quadratic function, then we want to use the quadratic formula. Our quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. So keep that in mind for the homework. On the last page, we're going to skip this. It shows up again later in chapter 2, so we'll just do it then. There's no questions like this on the homework, so just skip it.